Like many deep space scans, it started off that way, systematic and somewhat dull. The James Webb Space Telescope was tracking motion patterns and temperature data among known debris in the asteroid belt between Mars and Jupiter. Then something moved, not in a natural line, not in a regular orbit, floated, then slowed, and time in the control room paused for a second. It wasn't a rock. It wasn't ice. Spectral scans revealed manufactured, heat-retaining metal. Weak electromagnetic signals were released by it. Against the force of gravity, the question then struck more forcefully than any meteor. Why is it here in a community that we believe to be fully mapped? Something has woken up or arrived, and it's acting in a way that's unlike anything we've ever seen. Is it extraterrestrial? Is it old? Is it observing us? Science fiction is not what this is. The data is JWST, actual, inexplicable, and dynamic. This could be the first indication of non-aterrestrial technology, if you've ever pondered what it might look like. The unannounced visitor. The mission control room at JWST sounded the alarm. A swiftly moving object emerged between Jupiter and Mars. As the facts arrived, first responses varied from euphoria to stunned stillness. This was no known probe, comet, or asteroid. The trajectory defied Caparian laws and was confusing, winding in a different direction. Scientists glanced at each other. One said, "We've never seen this." The punch was provided by spectral scanning. Strong metallic fingerprints, modest yet steady electromagnetic emissions, and unexpectedly high thermal retention. Sunlight is reflected by rocks. This object had an internal light. It wasn't a gas blob, an ice body, or a real stone. Systems were double examined by engineers, and the findings remained consistent. This was novel. The group conducted an examination of thermal inertia. Metal and other non-cooling materials work well. That is illogical in the frigid belt of asteroids. JWST was able to monitor minute variations in brightness, and it was seeing an impossibility, something glowing from within. We must examine the asteroid belt itself in order to understand how rare this is. Our cosmic neighborhood is shown here. Stable routes were locked by thousands of diverse bodies. Anything in this area ought to act in a predictable manner. Let's examine why astronomers are suddenly reconsidering the belt and why this intruder contradicts everything we know about it. The asteroid belt is a known neighborhood that is situated between Mars and Jupiter, an area teeming with millions of rocks. The belt is stable and predictable, spanning from dust grains to series of dwarf planet sizes. The orbits of the asteroid families that our instruments have recorded revolve around the Sun like a clockwork pattern. Our unique Trojan and Hilda groups contain items stuck in Jupiter's gravity that have accumulated in designated parking spaces. These areas show the movements of cosmic order. To make sure nothing breaks the rules, JWST regularly verifies their trajectories. However, this item does not comply. Like a dancer breaking formation, it drifts. No steady pattern, no family association. Its chemistry is incompatible with silicates and carbonatous chondrites. It's not an ice comet or a normal asteroid. It just isn't appropriate. Astronomers were certain of what they would see because orbital paths were traced and entities were known. They were brought back to reality by this interloper. There are still many surprises in space. The question now is, why is it here? And where did it originate? We must understand why JWST is so effective at detecting faint moving objects in order to comprehend the discovery itself. Only the most sensitive instruments could detect a mid-flight slowdown, but its infrared eyes and tracking accuracy allowed it to do so. Let's examine JWST's methodology. The infrared vision of the James Webb Space Telescope is superior to those of earlier instruments. Even on dim planets in the asteroid belt, it can measure chemical and thermal emissions thanks to its imaging and spectroscopic capabilities. This makes it possible for researchers to detect faint signals and metal lines, otherwise undetectable. The mapping of thermal heat from small bodies, which tracks how they cool in the sun and glow at night, is another area in which JWST excels. It detects even the smallest motion by taking successive pictures. It witnessed the thing shattering in midair in this manner. Subtle movements that resist the pull of gravity. JWST uses radar in earthly telescopes to guarantee accuracy. Data from sources such as the Subaru telescope and Goldstone are cross-referenced with observations. The conclusion is strengthened by coordination. This is not a bug. There is a slowness. Then the pivotal moment arrived. The object slowed by meters/s in minutes during one thermal mapping cycle. There is no natural slowdown like that. The screen flashed with an enunciated signal. It was not a drifting item. It was dominating to self. Clonum 1. JWST detected metallic emission and absorption lines in the object's spectral fingerprint. Different signs, like as silicates or carbonates, were formed by rocky and ice substances, which did not follow these patterns. Rather than usual asteroid minerals, the findings were more in line with odd alloys, something created or unknown. Measurements of thermal inertia followed. Unlike rock or ice, metals retain heat much longer and cool more slowly after heating. That indicates that, like a heated iron rod left to cool overnight, the object gleamed faintly in between exposures to sunlight in the frigid asteroid belt. For things in the natural belt, that is abnormal. A slight electromagnetic buzz in the radio range was much more intriguing. It was weak enough to go unnoticed until now, but it was steady and had a low power, much above background noise. That signal suggested passive electronic activity or internal energy that needed to be ruled out. When combined, these hints are powerful, such as alloy-like spectra and sustained heat in an EM trace. They exclude common carbonaceous bodies, such as asteroids of the sea, or M-types. There was no match when compared to meteorite samples. The evidence clearly points to either a metal-rich composition, possibly synthetic, or something truly remarkable. The motion of the object is what solves the enigma, even though the spectrum shows metallic makeup. It's not drifting. It's maneuvering actively. Those mid-course corrections cannot be explained by gravity alone. Let's trace the path where JWST saw it disrupt orbital dynamics by braking and turning, and discover why scientists are referring to that movement as purposeful. The second clue revealed something shocking after a thorough analysis of the trajectory data. The object defied Kepler's principles by slowing down and shifting laterally while traveling. Motion in the asteroid belt is determined solely by gravitational influences. However, this item did not coast. It made purposeful adjustments to its direction and speed. Over the course of hours and days, JWST recorded several instances of acceleration and deceleration. These gravitational interactions were not subtle. These were deliberate, well-controlled movements. That behavior may be explained by even tiny thrusters, but no natural force can account for it. Models of collisions, gravity, and solar radiation pressure all failed. To make sure, JPL and ESA observatories, including as Odin, were used to cross-check the data. Both independently verified changes in velocity that fit the JWST profile. No timing errors or instrument artifacts. This was a genuine movement. The ending is unsettling. Like a spacecraft, this object is adjusting its trajectory. Scientists are unambiguous. It's not floating. It's steering. This is not how passive debris acts. This hint changes the item from something that piques your interest to something that might be designed. This thing starts to appear more like a craft and less like a natural visitor thanks to its metal composition and regulated motion. But let's consider a realistic possibility before we conjecture about wild origins. Is it a single visitor from space? Similar to an improved OMU exhibiting strange characteristics? Here's why researchers are thinking about that theory. Is this something from anywhere outside our solar system? Consider the 2017 discovery of Oumuamua, the first interstellar object. Its path went against the solar system's norms. Ours disregarded the laws of gravity. With its unusual materials and engine-like activity, it might also be interstellar. Spectral lines not present in elements from the solar system are revealed by spectrographic data. It might be composed of unusual interstellar alloys, but it also controls its trajectory and holds heat in a metallic way. Could an interstellar visitor use leftover gas or radiation pressure to transport shock-heated metal surfaces and limited self-propulsion? On statistical probability, scientists argued, we anticipate a few interstellar objects every 10 years, but none have demonstrated active motions. They conducted simulations to assess self-propulsion against gravity help. The object's braking is inconsistent with the acceleration that sunlight pressure is understood to produce. It was only possible with little thrusters. The deliberate motion needs to be explained, but the interstellar origin is still conceivable. Is it responding or powered? It's the most complicated visitor to date. If it's interstellar, a metal probe, moving at cosmic speed. Furthermore, that is more science fiction than fact. Hypothesis B, according to some scientists, it might be a remnant from the formation of our solar system, a 4.5 billion-year-old primordial item. Clusters of rock and dust came together in the early stages of the solar nebula, but many were expelled before they could fully develop. This item may be a remnant of Jupiter's early travels that has survived. It might include noble gases from the solar nebula, radioisotopes, or primordial isotopes that haven't been broken down by planetary geology. In order to date it to the formation epoch, scientists are looking for isotopic signals. It would be similar to having a frozen fragment of early solar history if verified. However, the majority of primordial relics are frigid or stony, lacking in metal and most definitely incapable of navigating. It is quite unlikely that a newborn relic from the solar system would have such a high metal concentration, demonstrate thermal inertia, and move precisely. The behavior and spectrum are not consistent with what would be expected from ancient detritus. Scientists are still receptive. Its uniqueness would make it an unreplaceable scientific treasure, an unopened time capsule. Assuming this is a primeval survivor, it might provide information on early collisions, planet formation, and the survival or destruction of early solar bodies over eons. The most explosive possibility is still present after investigating natural relics. Is this something man-made, intelligently created, possibly extraterrestrial? Its regulated variations, emissions, and metal composition all give away its design. Let's explore the possibility that this is engineering rather than nature. Hypothesis: what if this is a planned object? This is the inquiry that arises when all natural explanations fail. The object's electromagnetic buzz, interior heat, regulated movement, and metallic makeup are all consistent with what we could anticipate from a satellite or probe. There are comparisons to Earth technology. Cobots and other small spacecraft maneuver with the use of ion or plasma engines and metallic panels. The thermal signature, short pulses during engine operation, and persistent low-level glow are all consistent with what JWST is seeing here when a long-lasting RTG or reactor is added for power. If it is alien in nature, it might be an artifact or reconnaissance probe that was abandoned by a highly skilled engineer. It might be inactive, just sometimes pulsing to maintain location or control trajectory. The weak electromagnetic signal could be leftover equipment or a beacon to a parent who lives far away. The ramifications are astounding. Non-human technology was found in our solar system, concealed in plain sight. It provides an astounding response to the age-old question, where are they? In ways we cannot yet completely anticipate, verified, this will transform history, science, and our understanding of the cosmos. Such a conclusion needs to be examined by experts. Experts from spectroscopy, orbital mechanics, geology, and SETI provide guidance and prudence. Their opinions give the discussion depth and clarity. Let's hear the opinions of professionals. Interview format. We gathered opinions from a variety of scientific fields. A professor of planetary science said, a metal-rich object with propulsion outside expected formation trends. This challenges everything we know about asteroid belt populations. One spectroscopist weighed in. These absorption lines don't match known meteorite classes or any mantle-derived material. We've never seen this spectrum before. An orbital mechanics expert added, "This trajectory adjustment is deliberate. Such mid-flight slowing is not known to be caused by radiation pressure, gravity, or any natural process." SETI cautions that while we are interested, we are not yet prepared to draw the conclusion that it is alien in origin. However, the evidence continues to support that conclusion. Finally, an anonymous researcher said, "We're looking at something we can't explain, but until we have more data, we don't even know what the word probe means in this case." Their consensus is that the object is unique. Nothing natural seems to fit. But even though the idea of an artificial probe is interesting, it's still very strange. They are waiting for more information and staying careful as they try to find answers. Gravitational checkpoints. As the object's unusual path was followed, it started moving through what astronomers call a Trojan zone, a gravity-stable area created by the pull of a planet and the Sun. Specifically, it came close to Mars' L4 and L5 Lagrange points, where natural debris often stays in a delicate orbit. Trojan asteroids usually act in predictable ways. They group together, follow the planet's path, and stay in place because of the balance of gravity. But this object didn't stay. Instead, it moved through the zone without getting stuck or thrown out. Simulations from observatories showed both stable and unstable paths through the Lagrange regions. None of them matched the object's strange movement. It wasn't just moving,